Okay, good morning, everyone. Today is Tuesday, April 8, 2025. This is General Chemistry 1, Section 72, Spring 2024-2025 semester, and the time is 11 a.m. وكل عام وانتم بخير. بعضهم معيدين الشباب هونيك؟ معيدين بعضهم. Okay, طيب. Well, okay, we are in chapter number 7. I'm going to go ahead with chapter number 7. Chapter number 7. Okay. Now, I think last time we were talking about the chapter. You had a quiz, yes. So I talked very briefly about it. But today I'm going to talk in more details, and inshallah we'll finish chapter 7. I will make it as simple as possible, as usual, inshallah. And everything will be fine. Okay? Slide. Okay. Right. Okay, the chapter is about quantum theory and the electronic structure of the atoms. Quantum theory and electronic structure of the atom. Now, as I told you before, if you remember, I said whenever we have an atom, the atom, it contains protons, which are positively charged, and the neutrons, which are zero charged, yes? And there will be some shells around it. So that's shell number 1, shell number 2, shell number 3, number 4, whatsoever, they are shells. In the shells, we have subshells, subshells that are inside the shells. Subshells are inside the shells, all right? Okay, so as I'm going away from the nucleus, we have, for example, in here shell number 1. This is shell number 2. That's shell number 3. Shell number 4, and we continue this way. Okay, and if you remember before, we were talking about the way I look at the way I look actually at the atom. The atom, the way I look at it, I see it as a hotel. You remember the hotel I started with last time? It's the same hotel, huh? Okay. Now in this hotel we have floor number 1, floor number 2, floor number 3, floor number 4, floor number 5, and we can continue with the floors number. This hotel has a foundation, assess, and the foundation can take 1 billion floors, yes? But in this town, in that town, we don't need a hotel with many floors. We need only 7 floors because the population is limited, yeah? All right, but we can build up whatever we want later on. So this is floor number 1. This is floor number 2, floor number 3, floor number 4, 5, and we keep on going. This hotel is very strange. Now, it means in here, the whole area of the first floor is 1 room. Yani I call it royal room. غرفة ملكية. That means when I say room from now on, 1 room, how many people can live in there? 2 people. Okay, maximum 2 people. Right. Floor number 1 has got only 1 room. Floor number 2, how many rooms? It has 2. Floor number 3, how many rooms? 3 rooms. Floor number 4, how many rooms? 4 rooms, 2, 3, and 4. Is it okay? Yeah. Now, floor number 1 in here, if you go to floor number 1, you get out from the left, you will see actually, a door on the outside, and this door is labeled outside, it's labeled as S, room S. If I go to the second floor, I can get out from the left, and I see 1 room and the second room. There are 2 rooms in here. One is labeled S, and the other one is labeled P, SP. Third floor, it has S, P, and D. In here, S, P, D, and F. Floor number 5, 5 rooms. S, P, D, F, G, and then H, I, J. You continue with the alphabetic order. Yeah? We're not going to go further up. But now, when I go again to floor number 1, we have only 1 room. Floor number 2, it has two rooms, and this room P is actually having 3 compartments. Yani you open P, you open the door and you see 1 compartment, a second compartment, and a third compartment. Each compartment can take 2 people, all right? S is always 1. P has got 3 in here, 3 compartments. D has got 5, 1, 2, 3, 4, and 5. S1, P is getting 3. D, 1, 2, 3, 4, and 5. F is 7, 1, 2, 3, 4, 5, 6, and 7. The higher I go, the rooms are getting more rooms, and they're getting smaller and smaller and smaller. And the people living in each floor is getting a higher floor, more and more and more people on the same area. So, yeah, which means it's getting crowded in there. Right. Now, all right. Okay. Now, if I own a hotel, or anybody will own a hotel, inshallah. If you own a hotel, you don't run the hotel by yourself. It's very dangerous, okay? Because you don't charge friends, you don't charge family members, you don't charge anybody, and they get bankrupt, yeah? You keep away and you get what? Manager. You hire a manager. Now, the manager, you will tell him, because you are actually the owner of this hotel, you will tell him what they have to do in there. You give him a chart and you tell him in there. Anyone who will come, the first come, first served. And you tell them, there is a chart, he has to follow it. And this will be 1S, and then 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. ما عم تزبط معك. ما قلت لكم هلا عمل. That's what I said. 5S, 5P, 5D, 5F, 6S. I think I know what you're trying to say. 6P, 6D, 6F. Yeah? 7S. That's enough for me. Now, how many people can live in S? 2 people. How many people can live in P? 6. How many in D? How many in F? 14. Perfect. Now, you will tell actually the manager, he has the first come, first served. All they look the same. Electrons are the same. Now, you tell him, start with 1S. When you finish 1S, go to 2S, and then 2P, and then 3S, and then 3P. Now, I'm going to put the people who we are accommodating in there. People who are being accommodated. Let's put it in black. The first person will come, you put them in here, yes? Second person, he will share with him. 1 arrow up, 1 arrow down. I will explain what's up, what's down later on. Next customer will come, you send him to 2S, sorry? Next one, he will go in there. The next customer, you send him to P. You will tell him, go to P. He goes. Now, remember, P has got 3 compartments. No, that's okay. 3 compartments. 1 compartment, second and third. You open the door. This is 3P. You on the outside. You open it, and you see 2 beds, 2 beds, 2 beds. Where do you go? You go to the first one, or the middle, or the other one.
First one next to the door.
Exactly. You go to the first one because next to the door, you don't know the hotel. In case of fire or anything, emergency, you can escape. The next person who will enter, where he goes, would he stay with the first one?
No.
He will go to the next one. Now, this is very important, the sequence. Next one will go in here. Next one will go in here. Next one is going in here, and in here. Now we filled the 2P, yeah? Next, we go to 3S, 1, and that's the second one. Then 3P, 1, 2, 3, 4, 5, and 6. This is clear? Yeah. Next one, where 3D.
No, we go for S.
Why not 3D?
Because the function for one person only you can't make more.
Exactly. Maybe I said that before. Yes. Okay. Now, if I want to open a room D with 10 beds, that means and only one customer will sit in there. Next day, I have to clean the whole rooms in D, the whole rooms, and also change all the sheets, bed sheets. Yeah. So now I will tell him, don't go in there. Just actually, I will ask him to go to 4S. I will upgrade. I will say, go to 4S is better for you. Why is better for them? Because when he go to 4S, he's sharing only with one person instead of sharing possibly with 9 people. Okay, and also it's higher. You can have better view than before. Okay, perfect. Now we finish with the 4S. The next 3D, 3D. Now back to 3D. And then once we finish 3D, we go all the way down to 4S. Once we finish 4S, we go all the way up to 4D. And then all the way down to 6S, all the way down to 4F, all the way down to 7S. That's it. I don't need to go further because the number of people I want to serve are limited, maybe 120 people. Okay, I can fill the whole hotel up to here with all these customers. All right. Now, so what I said in here, I said you start, you finish 4S, and then you go back to 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Is this clear so far? Yeah, perfect. Now I'm doing this. Now I have some questions I want to ask you. 2 people can live in here, 6 people, 10 people, and 14 people. Where would you prefer to stay?
2 people.
Where? In which floor? طبعا. Why first? Because first floor is close to the reception. Every time you call them, they will be immediately in your room. Why? Because you are very special. Okay? It's a royal room. And now maybe he will get some money when you leave, okay, bakshish or whatever. Or if you don't give anything, he's happy that he met somebody important as you are. Yeah? Is it clear? The higher you go, what will happen? You are less happy, crowded, okay? If you are higher up, you call the reception, he will never go there because not only you are complaining, many other will be complaining and he cannot actually satisfy everybody, okay? So he will not go in there. You're not happy. The rooms are getting smaller and smaller. The floor is full of people in there, noisy. You cannot sleep very well. The higher you go, you are not happy. Now, the other thing we have to understand, we are all electrons, including myself. We all look the same. We have the same energies, huh? We look the same size, same weight, everything the same. Now, if we have energy, I have the energy. If I'm sitting in the first row in this classroom, I'm relaxed because I can see the board, I can hear the teacher, and now I'm relaxing. Still the energy in me, but I'm relaxing. People who are very far away, they cannot see very well, they're not relaxing, they cannot hear very well the lecture, and they will lose the interest, okay, of actually attending the lecture. They might leave as well if they want. Now, which means in here, they are complaining. How they complain, that means they show energy out. Their energy now is being shown. The energy of the first one, they are quiet, they are happy, okay, relaxed. The other one, on the back, the further you go away, they are more tense. That means they show energy, which means in here, I would say, electrons on the first floor, they have very low energy. When you go up, the energy will get higher, higher, higher. That means complaining, complaining, complaining. You understand? Okay, so the energy level, as I'm going to go from floor number 1 upward, the energy level is going to increase, yeah? Now, if I am living on the floor number 5, let's say, too many people in there, I'm not happy. I cannot sleep. Okay, I will keep on calling and looking at the mobile, find out another hotel to move there because I'm not happy in there. So, anytime I will have a chance, I will go to that hotel. I will leave, even I leave money behind me. Is that what will happen? Yes, in real life, because I'm not happy. Okay, all right. Now, this is how it is. Now, quantum. The title of this is the quantum theory. Quantum theory. Show the quantum theory. What's the quantum theory? Suppose I'm going to give the address, her address. Somebody from abroad wants to send a letter to her. What will be the address? How many information they have to give? Yalla. How many? Okay. لا. You all look the same. We are all electrons. We have the same name, same size, same look, same everything. Okay? We cannot differentiate.
Shell number.
خلينا a letter from abroad. First of all, you have to say United Arab Emirates. Huh? Then Sharjah. Then University of Sharjah. Then building M10. صح? Then which room? Room 110. So how many information now? 5. I did not reach her. Then what? Then the first row. Then what? Is it enough? No. The second one from the left. Yeah. Is this enough now? 7 information I need to get her. 7 information to get everybody of us. She and she, they cannot have the same 7 information. They might have the 6 same information, but the last one is not the same. The last information, she is the first on the left. The last information, she is the second on the left. Am I right? Now, let's see the address in here of the electrons. Let's say I'm going to look for this electron right in here. This electron in there. Can you see it? Okay, this electron. Now I go to the hotel. I want to deliver something to this person. I don't know where he is. I ask the reception. I need to go to this person. He knows where he is. What he's going to tell me? How many information? He will tell me, go to floor number 3. Yeah. If he stops in there, it's not enough because I know floor number 3, there are 3 rooms, S, P, D. Yeah. Then he has to tell me which room. He will tell me floor number 3, room SPD, room D. Is it enough? No, because I know D has got 5 compartments. Now he has to tell me, continue. He has to tell me that it is not the first compartment, it is not the second, it's the third compartment. Huh? Now I got 3 information. Is it enough now? Still, it's not enough. I know 2 will be inside. Now he has to give me a 4th information. Now, what is going to tell me? He will tell me, look at the arrow, 1 up, 1 down. So now he will tell me, when you go to this room, do you see 2 beds? One bed, his head is by the window, and the other bed, his head is against the window. Yeah. Now he will tell me, now he is in the bed which is against the window. Do I need any more information? So how many information I need? 4 information. And this 4 information, we call them quantum numbers. يعني quantum number بيخوف when we say quantum, okay? But it's nothing. Quantum numbers, they are numbers. But since they are numbers in here, remember what we did in there. We labeled each room S, P, D, F, G, H, I, J, whatsoever. These are numbers or letters? Letters. The numbers. Now what we have to do, we have to change everything in the hotel. We have to take the label which says S and we have to put instead a number. Now, the S in this case, we're going to change it and we're going to change it to 0. S, P, D, F, yeah? And P will be how much? 1. S, P, D will be 2. F will be 3. F, G will be 4. And so on. It will be 5, whatsoever, so on. You understand? Now you go to the first floor, you don't see, or this third floor, you don't see SPD, you see 0, 1, 2. Is it clear? Perfect. Now, I need to give the address, the 4 quantum numbers in there. Okay, we have 4 quantum numbers, 4 quantum numbers in there. I have to give the 4 quantum number for every electron inside this hotel. Yeah, what we can do in here. Now, the number in here, we have 4 quantum numbers. 4 quantum numbers. What are the 4 quantum numbers? Very simple. These are the 4 information. The first quantum number, we call it the principal quantum number. Principal quantum number. Or we call it the shell number. Shell number. This is shell number or principal quantum number or the shell number. And we give it a symbol of small n. Small n, yani this is the shell number. Yani the floor. Which floor? And the shell number in here, it goes from where? It is equal from where? It goes from 1 to what? To infinity, because I can have so many, right? Remember, floor number 50, how many rooms it has? 50 rooms, huh? Floor number 1000, how many rooms? 1000. And the rooms are getting smaller and smaller, okay? This is the shell number. It goes 1, 2, 3. Now we don't have more than 7 floors, okay? Up to now. The second quantum number is called, when we say principal, yani the next one will be secondary. Secondary quantum number. And we will call it in here the subshell. Subshell. You know what is sub? It is subway. What is subway? Subway, there is a way. Subway, that means inside. Yes? Subshell in here. The subshell, we give it a letter, a symbol of L, small l, subshell. That, as I said, floor number 1, how many subshell? 1. Floor number 5, 5. All right? Now, the L, the value of L goes from where to where? The value of L, it goes from how much? From 0 to n minus 1. Yani if you have, for example, if n equal to 4, L will be how much L? It will start 0, 1, 2, and 3. Is it okay? Perfect. That's the this is actually the subshell. The next, the next quantum number is called the orbital quantum number. Orbital. The orbital quantum number. Orbital quantum number. The orbital quantum number, we give him a symbol M and subscript L, ML. And the ML will go from where to where? ML, it will actually go from, any idea? From minus L to plus L. Yani it goes from minus L to plus L, passing through 0. Yani if L is equal to 2, L equal to 2, L equal to 2, which one? S, P, D, صح? D, how many rooms? How many orbitals? Now, division in the orbital, how many? 5. So the D in here, that's the D. Yes, we know it as D. It is 5. Okay, 1, 2, 3, 4, and 5. Now, how are we going to label it? Is that going to tell me the first, second, and third? This will be 2 start from minus 2, صح? Minus 1, 0, plus 1, plus 2. Is it clear? So it goes from minus L to plus L. If it is S0, it goes from minus 0 to plus 0, yani ML will be only equal to 0. Yeah? The last quantum number in here, the fourth quantum number in there, so we have 4. The fourth quantum number in there, no. Okay, the fourth quantum number, we call it the spin number. Spin number, and we will call it M subscript S. And the MS, how many people can live in each orbital? 2. One, his bed is opposite to the other bed, صح? So it will have one is going to move up, and the second one is actually going down. The one that is going up, we give a ms equal to plus half, and this one will be minus half, plus half and minus half. Okay, plus half, and this is minus half. Minus half. Is this clear? With this, we can get every element. We will find its quantum number, the fourth quantum numbers of every element. All right. Let me go back to this one. Remember, we were talking about this electron, yes? I want to find the address using the four quantum numbers. Now, the n for this one will be equal to how much? L will be equal to how much? ML will be equal to how much? And MS will be equal to how much? Yeah. First of all, where is this one? I'm talking about the red one. Where is the n? 3. So n is equal to 3. Perfect. L is equal to what? SPD. S0 PD. Bravo. This is actually 2. Yes? That's 2. ML. What we said? We said the ML, it goes from -2 to +2. Yani from here, this is -2. صح? -1, 0, +1, and +1. And this is +2. Now it is 0. Perfect. MS is it what? Minus half. Excellent. Minus half in here. Now that's perfectly okay for this electron right in here. That's the address for this electron. Whatever electron we want to give him the address, we can actually give the address. Yeah. It is impossible that two electrons will have all the same four quantum numbers. This one in here, you can see it, yes? This one and this one and the red one, they have the same 3 quantum numbers, but the last quantum number is different. The black one is actually plus half, the red one is minus half, and that's what we make the difference between them. Yes, quickly.
But quickly for the, and if it was fourth floor, because you said L is n minus 1. I know from that. L is n minus 1. Why?
Sorry.
And then
L,
yes, L n minus 1. You wrote this.
L is from L is from 0 to n minus 1. From 0 to n minus 1. That's what I said.
Okay.
N, L. From 0 to n minus 1.
Yes.
Okay? Like this one in here. N is equal to 3. So it went from where? It went from 0 to 3 to 2. Yani 0, 1, 2. SPD. Okay? Perfect. Now, these are the 4 quantum numbers. The question in here, why plus half, why minus half? What is actually about the spin number? Spin number. Okay, شو spin number? We called it شو اتفقنا? MS is the spin number. It could be either plus half when it is actually moving upwards, and it is minus half when it is actually moving down. You remember the electron is going to move around the nucleus, yes? The electron, when it moves around the nucleus, as it's moving around the nucleus, it's moving, rotating around the nucleus, and also it's rotating around itself. Yeah, like the Earth is rotating around itself and moving around the sun. So, okay, the electron this way. When the electron, if this is the electron is moving in this direction. North is up, south is down, moving in this direction at an extremely high speed, incredible speed. Who lives on campus here? You live only with 1 or 2 people? 2. Now, if I'm going to live on campus, I go to the reception, they will tell me, go to that room. I go to that room for 2 people. I see 2 beds, 2 wardrobes, 2, everything. Which one I choose? I choose the best, or I choose here best, bed, best, bed. What? Would I choose the best thing?
Yes.
Of course. Why? Why? Logic. Why? Because I am mean, I leave everything for the second person to get the bad thing. أنانية يعني هذه؟ No. Because maybe nobody will come, صح? Maybe nobody is going to join. So I will take the best. Now, this person, he took the best. Now I come as a second person. I go to this room, and then I have a maid in there, a person who's going to live with. But I have whatever left for me, I have to take them, صح? Would I be happy? Not at all. What I do in here, I have two options. Either to fight with him. I said, no, you took everything, the good thing, we have to divide them between us. So we have to fight. He will not say, okay, he say, I come first come, first served. So I would say, no, it's not fair, Mother Show, and we have to fight. When we fight, we get both out from the college. We don't have any more accommodations. Huh? Second option, I will take whatever. I have to compromise. I will take, and I go, I put my stuff, I go to the reception, and I will tell them, put me on the waiting list. Whenever you get another room, send me in there. Say why I don't like this person. خلاص, he's mean. I don't want to live with him. Yeah. But now I stayed with him. That means I compromised. Am I still happy? I'm not happy. Next day I wake up, he wakes up and he will tell me, good morning. What I tell him? What morning? I do not sleep. You're sleeping very well. The bed is bad. The pillow is very bad. Everything is bad. You are having good time. I'm having bad time. And now we are fighting again. So? And then I realize if you keep on fighting, both will be out. Then I relax. And fighting, relax, fighting, relax all the time. So? Now, I don't know if you played a game when you were kids, or maybe still now you play the same game. I don't know. I can play it maybe still. Okay. Now there is a game which actually I'm sure you are maybe familiar with this toy. هذا اسمه, we call it in Lebanon, we call it bilbul. You know what's a bilbul? It's something, and you put a thread in here. You put a thread, and then you put a thread, and you throw it on the floor. It starts spinning. Yeah. Have you worked with this? Do you still have it? You still have it? Really? Like, get two of them. And you can try it at home. If you get through two of them, and now look what will happen. Okay? Spin this one on this direction, on the floor. Throw the second one spinning in the same direction. Look what will happen. You know what will happen? It will happen the following. This will move, they touch each other. Once they touch each other, what will happen? They will go away. Would they come back? Never. Never. Once they hit each other, they go and they can never come back. But if I spin the first one in this direction and the second one in the opposite direction, when they come together, they hit each other, they go away, they come back, they go away, they keep on coming back and going away. That's what will happen to me because I compromised with the other person. We are fighting and then we are friends. Fighting, friends to survive, to stay in the same room. Because if I want to keep on fighting with him, both will be out. I'm going to lose my accommodation. Okay, so now I did compromise. I took something bad in order to survive with this guy in the same room. I'm not happy, but sometimes I might be happy. I have to compromise. I have to swallow it. Yeah, you understand? Okay. Now, when you have the electron, now خلصنا من بلبل. When you have the electron in here, the electron, if that's the north in there, and that's the south in here, the electron, let's say, spinning in this direction. North, up, or that direction, doesn't matter. It's spinning in this direction. Let's say it's spinning in this direction. The second electron, when he comes, if he's going to spin in the same direction, they cannot exist together and they will be boofed out completely. Now he has to spin in the opposite direction. Yani, it means the electron spinning in this way, he has to stop and start spinning in the opposite way. He cannot do it. It's not a car that you change the gear and you go reverse. Yeah, it's not possible. Now, high speed, extremely high speed, no brakes in there. He's spinning all the way in there. Now, as he's spinning all the way, now the first electron who get to this room, the room is empty. It has two beds. The first electron naturally spinning in this direction. He goes inside and stays spinning in the same direction. صح? The next one, when he comes, he sees spinning out from the same direction, on the same direction naturally. And then when he sees him spinning in this direction, he has to spin in the opposite direction. He cannot stop. How he can spin in the opposite direction? If I turn my hand upside down, شو بصير عندي? What will happen? Opposite direction. Still spinning very fast, but now moving upside down. The north is down and south is up. Okay, so the second one in there is going to spin in the opposite direction. That's the one, and now it's spinning in the opposite direction. Once they're spinning, one spinning this way and the other one spinning in the opposite way, they hit and they come back, they keep on actually existing together. Is it okay? And that's why we say this is actually the MS for this one. It is plus half, and this one is minus half. Is it clear? Yeah? Good. Done. Okay. Now, let's move a little bit further and let's talk about electron configuration. Electron configuration. Now it means I have to follow the chart. You remember the chart? I drew it for you. Okay. Now we can say in here, write the electron configuration. We have to write the electron configuration. Now, I look for the element. Let's say I'm having an element which is 19. Atomic number is 19. And it has 19 electrons. So to write the electron configuration, I put a column in here, and then I start. شو بنقول? 1s2 صح؟ يلا 2s2 2p6 3s2 3p. Let me count them. This is 10 electrons, and in here how many electrons? This is 6 in here, that's 18, and then 4s1. Do you remember? Now I'm having 19 electrons. The other thing they might ask me, they will tell me, draw the orbital diagram. بدي ارسم. Draw the orbital diagram. Orbital diagram. Draw the orbital diagram. Orbital diagram, since I'm having the electron configuration, S has got only how many rooms? 1. S, 1 room, صح? P, how many? 1, 2, 3. S, 1, and this is 3, 1, 2, 3, and this is actually 1, yeah? Now I want to put the electrons inside. 2 electrons, 1 up, second one down. Up, down. 1, 2, 3. Remember the filling, yes? 4, 5, and 6. 1, 2. 1, 2. The opposite, yes? 1, 2. 1 and 2. 1, 2. 1, 2, 3, 4, 5, and 6. 1. Yeah? When you see 2 people in one room, that means we say it's a paired number of people. In here, paired number of electrons. Paired, unpaired. صح? This one in here is unpaired, and that's very important in here. Unpaired number of electrons. How many unpaired number of electrons I'm having? 1. Now, depending on the paired electron, if I'm having all of them paired and some of them are unpaired, I will say that this atom in here, this atom is actually paramagnetic. It is paramagnetic in this case. شو يعني paramagnetic? It means if I'm having the atom, this atom, and if I approach a magnet, approaching the magnet, this will be attracted to the magnet, and that's why we call it paramagnetic. The more unshared electrons, the more attraction will be. Yeah. Okay. The more unshared, unpaired electrons, the more is the attraction. Paramagnetic. Okay. So I would say in here, attracted, this atom will be attracted to external magnet to an external magnet. طيب. Now, if there is no unpaired electrons, if we have no unpaired electrons, we call the atom will be called diamagnetic. Diamagnetic, it means it will not get attracted by the external magnet. Is it okay? تذكروا دايا يعني two. داي يعني two صح؟ diamagnetic يعني you don't see in there lone pair of electrons. You don't see electrons alone, unpaired electrons. All right? Now, I think I give you everything you need right now. Okay? Now I'm going to go through the slides. All right? Let's go through the first slide. Schrodinger wave. Now, again, we have 4 quantum numbers. I'm going to stick to what we want to cover in here. We have 4 quantum numbers in there, and the 4 quantum number, we start with the first quantum number, and we called it the principal quantum number, and we give it a symbol of n, and that's a floor number, if you remember. Okay. Now, this is the distance of the electron from the nucleus. Okay. Now, quantum numbers, the 4 quantum number are the n, l, ml, and ms. These are the 4 quantum number. Again, the value of the first quantum number, the principal quantum number, or the shell number, it goes from 0 to n, from 1 to infinity. But the second quantum number in here, which is subshell, the subshell or the secondary quantum number, it goes from 0 to n minus 1, from 0 to n minus 1. That's the L. If n equal to 1, okay, L will be equal to what? L will be equal to 0, and L will be, that's it, 0. Okay? N equal to 1, that means it has only one subshell. The one subshell is S, and therefore in there the L will be only one compartment. All right? If n equal to 3, let's go to 3. N equal to 3, then it will have what? It will have L will be 0 to n minus 1. يعني 0, يعني هذا ال S, P, D. 0, 1, and 2. From 0 to n minus 1. All right? Now, of course, you know in here that the S, we called it already 0. We labeled 0 as number. P is 1, D is 2, and F is 3. And we keep on continue. We're not going to label S anymore or P anymore. Okay, now, again, ML goes from where to where? From minus L to plus L, all right? Now, if I'm having P is what? S, P at the 1. Okay. P, if this is the P in here, which means it is equal to 1. So it has 3 compartments. It goes from minus 1, passing through 0, up to plus 1. D, from minus 2, minus 1, 0, plus 1, plus 2. You go from left to right, from minus to plus all the time. Okay. Now, again in here, when it is equal to 2, that's D, it goes from minus 2, minus 1, 0, plus 1, and plus 2. Okay, and plus 2. All right? Okay. In here, the spin number, as I said, spin number, this is spinning in this direction in there. The north is up, south is down, that's the electron. If the second electron has to come in there, he has to turn upside down to spin in the opposite direction. And we say this is actually plus half the first one, that's the plus 1, and that's the minus 1 for the second one. All right? Plus half, minus half, okay? Right. Okay. We move a little bit further. We don't need a lot of things in here. ML, okay. Now, what are the allowed values of ML? For n equal to 4, is an n equal to 4, floor number 4, how many rooms we have?
3. 4 rooms.
4 rooms. So what we have in here? 0, 1, 2, and 3. 0, 1, 2, and 3. What are allowed values? ML, N, L, these are the L, ML, when L equal to 1. When L equal to 1, that means ML goes from minus L to plus L. Yani it goes from where to where? From minus 1 to plus 1. Minus 1, 0, plus 1. Always we have to pass through 0. Yeah? Okay? Let's see what they have done in here. That's it. We're not going to read everything. It goes minus 1, 0, plus 1. Is it clear? Yeah? Good. Now, again in here, if you have, for example, n equal to 3, for n equal to 3, the L will be 0, 1, 2. And for the L equal to 0, ML will be 0. For 1, minus L to plus L, from minus 1 to plus 1, from minus 2 to plus 2 in here. Now, number of orbitals, how many orbitals? SPD, remember that's SPD. How many orbitals? This one will have 1 orbital, this one will have 3, this one will have 5. These are the division in there. 3, 5. Okay? And that's it in there. We will talk more about it. Now, probability density. What is the probability density in here? Probability density. Now, if you have the nucleus, if that's the nucleus in here, that's the nucleus, protons and neutrons. Electrons are moving around the nucleus in 3 dimensions. Talking about the S, moving in 3 dimensions in there. How it going to move? The electron doesn't go in a straight line. It goes as a wave. Yani if I want to make it in here as a wave in there, the electron moving in here is going to move as a wave around the nucleus. Keep on moving at a very high speed. Doesn't stop, never stops in there. It never stops in there. Keeps on moving all the time. That means practically what it will make behind it. Remember, that's like a Superman. Moving so fast. You don't see Superman, but you see the way, the path he's passing. Yes? Now I can see now a cloud. It's a cloud. The cloud in here, it has a certain thickness. That's the thickness of the cloud. What does it mean? It means anyway, the electron that is moving this way could be any way in there. Where, I don't know. I have to say stop, and then I find where is the electron, and this will never happen. Yeah? So that's, we call it the electron cloud, which means it is the probability, ihtimal. Now, we're talking statistics in here. That's called the probability where the electron is inside the cloud. Yani you have a cloud, there is airplane, the airplane, I can see it, suddenly it disappears in the cloud. Where is the airplane? The airplane could be anywhere in the cloud. Huh? The only way, if I remove the cloud, I can see the airplane. You understand? So that's called the probability in here. Now, again in there, 90% of the electron density is found for the orbital. Now, all of this, the electron could be anywhere in this orbital, anywhere in this orbital. And that's 1s, 2s, 2p. Every s is moving in this direction. That means forming a sphere. Let's move a little bit further to understand it much better. Now, atomic orbitals, okay? When we talk about 1s, if that's the nucleus in here, 1s moving around the nucleus. 2s, for the 2s in there is the nucleus, 1s, and there is 2s. That means 2s is bigger. 3s is even bigger. That's a 3s is even bigger, and so on. That's regarding the s. So the s, the electron in s orbital is moving actually around the nucleus in 3 dimensions at a very high speed. But the p in here, so that's the s. Remember, the s, I'm having how many electrons maximum? 2 electrons. How they're moving? They're moving in a sphere. But when we talk about the p, how many compartments? 1, 2, 3. 2 can be in the first one. In the first one, 2, 2, and 2 electrons. Yes? How they're going to move in there? The 2 electrons in P is different. Now, that's the nucleus. The two electrons, the first two electrons, they move like this. If that's the nucleus, they move this way, this way, this way in 3 dimension. Okay? They move this way on the x-axis. The other two, they move in the y-axis. You understand what I'm doing? In the y-axis, like a letter 8. The other one, sorry, the y-axis up, the y-axis, and the other one in the z-axis, x, y, z in 3. Now, which means these two will move in the direction as px, py, pz. Px moving in this direction, Py moving in this direction, Pz moving upwards. Okay? And these are the 6 electrons. Look how complicated it is. Where is the central atom? The central atom is in here. So these are moving. P, we cannot have P electrons unless we get S before. So yani we have to get 1s2, 2s2, 2p. Yani already too many electrons, all moving around the nucleus. Now, if I'm having roundabout, any roundabout, even a big roundabout, and 2 cars are moving in there slowly, would they get accident? Probability is there, yes. Maybe somebody will get heart attack and hit. Maybe something goes on, they hit each other. That's at the low speed. At the high speed, what will happen? The chance to get accident will be much more. But now the electrons are moving extremely fast, incredibly fast. Too many electrons around the center. Would they hit each other? Logically, yes. But if they hit each other, what will happen? They will be knocked out away from the atom. Huh? That means the atom will not be any more atom. Okay? That means we'll never exist because we are made of atoms. Huh? But these electrons are moving extremely fast in a very small area, small roundabout, very high speed, and they will never hit each other. And if you ask why, شو قلت أنت؟ Subhanallah. They never. Because if they hit each other, they get scattered away, and we will never, nothing will exist anymore. You understand? Okay? Right. Now, this is how the p orbital, how the electrons in the p subshells are going to move in there. If you have d, what will happen to the d? 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Now it's much more complex in there. If I want to look at the D, look at the D in here. So these are the orbitals inside the D subshell. 1, 2, 3, 4, and 5. The 2 electrons, look how they move up this way and then this way and this way. And it's incredibly. And this one, you can see a donut in here, like a donut. Huh? Okay. And don't worry about this. These are the shape of the S, of P, of D. F will be even much more complicated. Okay? We're not worried about it. Now, list the values of N, L, ML for the orbital in 4D. You have 4D, صح? That's a 4D. 1, 2, 3, 4, and 5. We want to find the N. We want to find the L. We want to find the NL, ML. ML. Okay? N equal to how much? N equal to 4, that's for sure. L will be how much? From 0 to 3. 0, 1, 2, and wait a minute. L from what? L from 0 to n minus 1, from 0 to 3. Okay, that's right. 4 معناتها.
L is 3.
That's it. Sure?
L is 3.
No. L لا صحيح. L is what?
Because it's given 4D.
L is from 0 to L. L from 0, so N is whatever. N is from 1 to infinity. L is from 0 to n minus 1. Okay, that was correct. 0, 1, 2, and 3, right? ML will be how much? ML depends on L. it goes from minus L to plus L. Yani for this one in here, ML will be equal to how much? ML will be minus 2, minus 2, minus 1, 0, plus 1, and plus 2. صح? And in here goes from minus 3 to plus 3. All right? So these are the possible ones in there. Let's have a look in there. All right? ML will go from minus 2 to plus 2 in here. That's it. All right? That's the ML. And where are they saying things in here? Solution. N equal to how much? N is equal to 4. N equal to 4. That's a 4D in here. Okay? Goes from minus L to plus L. That's what I said. It goes from 0 to 3. Okay? L goes from 0. L goes from 0. L goes from 0 to 3. Now they took the one that is 2. If it's 2, the ML will be from minus 2 to plus 2. Yeah? If it is 0, it goes from 0 to 0. Okay. Right. Now, orientation in here, ML equal to ML if you have, which one is this one? L equal to how much? 1. Yani SP. Now we're talking about the P in here. That means P, L equal to 1. صح? Yeah. ML goes from minus 1 to plus 1, minus 1 to plus 1, passing through 0. That's a minus 1 plus 0 plus 1. Yeah? Okay. Now again, if, okay, now if L is equal to 2, ML goes from, يعني هذا شو? SPD. It's a D, okay? So that's the D subshell. It goes from minus 2 to plus 2, passing through 0 ML. It means this is the minus 2, minus 1, 0, plus 1, plus 2, and so on. Is it okay? Yeah?
We can find the number of shell, right? And
You can always, we will come to this one. What is the total number of orbitals associated with the quantum number n? How many orbitals? N equal to 3. This is the shell number. Subshells, what are the subshells? 0, 1, 2. L is 0, 1, and that's 2. In how many electrons in 0? Number of electrons, 2 electrons. In P, how many? 6. In D, 10. These are the number of electrons. If I add them all together, this will be equal to how much? 18 electrons. That's as simple as this. Now, that's one way to find how many electrons can live in the third floor. How many people can live on the third floor? Instead, I can say 2n square. That's the number of people. Yani, take the 3 as n. Take n equal to 3. Yani 2 multiplied by 3 to the power square. And this will be equal 9. And this will be how much? 18. That's the same. If you have floor number 7, for example, n equal to 7, then 2n square will be equal to 2 multiplied by 7 squared, and this will be equal to whatsoever. That's as simple as this. Yani whenever I ask you how many electrons are in shell number whatsoever, take it as 2n squared. That's easy for you. You don't have to count them by hand. All right? They should say somewhere 2n squared somewhere in here. Now in here they did count it in there, but it should be 2n squared somewhere. We can see it maybe in other slide. These are the quantum number in here. Now, existence and energy of electrons in atom is described by its unique wave function. Pauli principle, Pauli exclusion principle. You have to understand this because sometimes we ask about it. Pauli exclusion principle, it tells us that there is impossible, that means no 2 electrons in an atom can have the same 4 quantum numbers, yes? And that's what we said. They can have the same N, the same L, the same ML, but maybe different MS. All right? This is the principle in here, of the Pauli principle. Now, quantum number again, and whatever. The shell is the number of electrons in the same value. N subshell will be L. Okay, we did that before, so we are repeating. And this will be ML, will be the orbital. That's what we labeled, صح? Okay, let's move again a little bit further. Now look in there. When we say that's the energy is going up, okay, the energy. As I'm going up within the floor, I say the energy is getting higher and higher. 1s will have the lowest energy. They are very much relaxed. 2s will have more energy. 2p slightly more than 2s, okay? 1s, 2s, 2p. 3s higher, 3p higher a little bit, and then 3d, okay? But where is the 4s? We did not fill 3d. Remember what we did in there? We started with 1s, yeah? Now I'm going step by step. 2s, 2p, 2p, 3s, yani the last wall I'm building is 2p now, okay? Notice what I'm doing. I'm building one wall, 1s, 2s, 2p, 3s, 3p, 4s, then I go one step back. So, yeah, the last wall is what? 4s. You understand?
Okay.
Okay. Every time I'm going to D, I have to go one step back. Every time I go to F, I go how many steps? Okay. When I go to D, I go one step back. When I go to F, I have to go 2 steps back in that. All right. Yani when I get to 6s, after 6s, I have to go to 4f. You understand? Okay. Keep this in mind. All right. Yani, okay. Now we can see it much better right in here. Look in here. We went 1s and then 2s. Yani energy is getting higher, صح? And then 3s, صحيح? 1s, 2s, 2p. هيدا البي، هيدا 2p. 1s, 2s, 2, 1s, 2s, 2p. 3s higher. 3p is higher. 4s is higher. And then we go to where? 3d. Where is it 3d? 3d is even higher. So always S is the lowest energy. P higher, D higher, F higher energy. Okay? Keep this in this sequence in there. And then 4p and so on. So that's the level that we have to keep in mind. Now, again, we have 1s, 2s, 2p, 3s, 3p. 4s is lower than 3d in here. Yeah?
Less energy.
More energy. You can see the energy in here. The energy, the slide before is wrong because the energy of 3D is higher than 2s and than 4s. You understand? Because the energy goes up as you go through the arrows. If you follow the arrows of the the arrows I showed you in the chart, you remember the chart 1s, 2s, 2p? The arrow will tell you, as you're following the arrow, the arrow will tell you which one is higher than the other. All right? As simple as this. So the 3D comes after 4S. Yani 3D has got higher energy than 4S. طبعا it will have higher energy. Because if I'm living on 4S, I'm sharing the room with only one person. I'm more relaxed than living on the 3rd floor with sharing with 9 people, where I feel more relaxed. Sharing with one person or sharing with 9 people? طبعا. That means this is actually, I am more relaxed. This is, I'm not relaxed at all in 3D. Yeah? Okay?
But Doctor, if we look at 5s and 4p, it's the opposite of what you're saying. 5s and 4p.
Okay, 5S, 4D. 4D is higher. For what?
4p, it's,
4P is different. Follow the chart. Follow the chart. You will see them in sequence. If you follow the chart, that's how you fill the electron configuration. Okay? Now, let's have a look in here. Now, this is absolutely incorrect, صح? You don't fill it this way. And this one is what? That's correct, صح?
No.
Absolutely incorrect. One up, one down. No. This is what?
Correct.
That's correct. This is what?
Correct.
Correct. And that's it. That's for the other one. The sequence, always fill it one by one up, and then you are forced to put the second one down. That's the one, the chart. I give you another chart which I am used to it. Which chart you want to have, you can adopt whatever you want, all right? Based on your convenience. Write the 4 quantum numbers for an electron in 3p. 4 quantum number in 3p. شو يعني 4 quantum number؟ يعني n, l, ml, and the ms for the ms. Okay. Now 3p يعني you have actually what you have in there. You have 1, 2, 3. That's a 3p. Yeah. Now n equal to what? 3 definitely. L equal to what? 0, 1. L equal to 1. ML could be what? Minus 1. It could be 0. It could be plus 1. صح? MS where it could be either plus half or minus half. بس ما في شيء تاني. And we can fill the electrons as they are. Yeah? All right? It's very easy and it should be fine. So that's our the thing in there. All right? So these are the 4 quantum number. 1, 2, okay, so that's actually, okay, so that's 0 and plus 1. From minus 1, passing through 0, going to plus 1, and each one will have plus half, minus half, plus half, minus half, plus half, minus half. Yeah, okay. Electron configuration, again, I talked about the electron configuration. Remember the electron configuration? You look at the chart, you follow the chart. If you ask me to write the electron configuration of any atom, you give me the atomic number, and then I will draw the chart next to me, and then I can go through the chart. I don't have to memorize it. Now, and then once you have the electron configuration, you can write or you can draw the orbital diagram. In here we say you write the electron configuration, but in here we say you draw the orbital diagram. Is it okay? Okay, we can have some more examples later on. And now again, this is actually the spin, the ms. We're talking about the ms, the spin number in here. The spin number, either it can be plus half or it can be minus half, how they are spinning. North up, south down, this is plus half, that's minus half, and so on. Now, if it has, okay, if it has like this one, it has unpaired electrons, what we call them? Paramagnetic. Unpaired electrons. All paired electrons, we call them diamagnetic, as simple as this. This will be attracted by the external magnet, and this will not be attracted by the external magnet. Is it clear? Good. What is the maximum number of electrons that can be present in the level of n equal to 3? How much will be? 2 multiplied by 3, that's why we did it already, and that's equal to 18 electrons. It should be 18 electrons. That's the easiest way that we can do. If you're doing this way, if you count them, they're going to be 18 electrons. Okay, so 2n square, and that's 18 electrons. There is no need to read it for you. You want me to read it for you? Okay, right. Now, an oxygen atom has a total 8 electrons. So you have oxygen in here and 8. Is it 8? 8 electrons in there. Write the 4 quantum number for each of the 8 electrons, for each one. Okay? Let's take only one, yeah? All right. So this will be what? 1s2, 2s2, right? 2p at the 2p4. يعني هون we're having 2 electrons, صح? This will have orbital diagram, and this will be what? 1, 2, 3, 1, 2, 3, 4. Let's find the 4 quantum number for this one. بس لو واحد منهم, okay? What will be the quantum number? N, L, ML, will MS. يلا. N equal to 2, bravo. L equal to 1, yeah? S, P, okay? ML, minus 1, 0, plus 1. So that's equal to negative 1. MS, beautiful. Yeah? Is it easy? Okay. Now that's a strategy in here. Apparently, so that's what they did in there. 3, P4. They give us all of them. You want me to give it all of you? All of this? Yes?
We have it in the table.
No need. Shukran. Okay. Right. That's a table. Do you have to memorize it?
No.
أكيد no. Okay. The author maybe Amit Sallah, he doesn't have a lot of things, you know, and he put them in there and he gave it to you free of charge. All right. Now we have 5 minutes. Look at this table in here. That's a periodic table. Can you see something? In here, if you look at it, you can see that these are how many columns? In here, how many? Any idea? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. In here, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 columns in there. These are 2 columns in here. These are 6 columns in here. These are how many columns? Any idea? 14 columns. Yani, because they are the columns, I can call the whole area here, this area in here, I call it S area. S area. هذه للS. 2, 6, 10, 14. S, P, D, F. صح? Now, this whole area in here is the P area. The area in here is the D area. That's the D area. And here is the F area. F area. How we count them in there? We can go. This is actually S. That means any atom in here in the group 1A, it should end up, electron configuration will end up with S1. Is this clear? All of this in here, they will end up with S2. يعني electron configuration between 1s2 to s2 blah 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 and should end up with s2. In here they will end up, this will end up with p1 and this one p2, p3, p4, p5, p6. Okay, every atom in this area, in this group, it should end up with p5. Which p5? You go to the shell number. Shell number 1, shell number 2, 3, 4, 5, 6, and 7. Now, if I look at this atom right in here, it will end up with what? It should be 1s2, blah, 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 5p, p1, p2, p3, p4, p5. You understand? The area, this will be D1, D2, D3, D4, D9, and this D10. Yeah? In here, F1, F2, F3, F4, F13, and F14. That's it. Now I can know from the position of the element in the periodic table, I can know this element where it's going to end up with. All right, so this is actually called the area of the S, P, D, and F. Is it clear? Okay, and I think we will stop right in here. Can you know which slide it is exactly?
Actually, only 2 slides.
لا هي 2 only 2.
هذا الاكزامبل بس هذا الانسر تبعه بس هذا السوليوشن يعني تبع الانسر.
خلص. Okay, next time I will finish it and I will start chapter هذا which chapter?
7.
We go through 8. 42. هيدي slide 42. Okay. 42 40 يعني خلصنا خلصنا ال 41 7 41 اهلا 7 42 وبنكفيها. Good. الله معك.